How's it going, everybody? We are Group 4, and today we'll be discussing a couple of topics: Boolean retrieval, information retrieval, term vocabulary and posting lists, web search basics, and my name is McNair Bledsoe, and these are my other teammates. I'm going to introduce yourself too.
Hi, I'm Naveen.
Hi, I'm Hari.
I'm Manali.
Alright, we'll go on to the basics, which is information retrieval. A definition for information retrieval is finding material of an unstructured nature that satisfies an information need from a large collection. We use information retrieval systems to reduce the information overload, and I found a good many fun terms here like infoxication, infobesity, data smog, infoglut. You can imagine what that is. We use these to retrieve information from a large collection of data. So instead of like a library system going in and just seeing this massive amount of data and just looking one by one, we have actual indexes that we can go and find what we need. The most visible use of this and the common day is web searches, Google, Yahoo, etc. Now, for these to be ready to be searchable, we need to turn these documents into something that can be read. This can be either by turning documents into something represented by words or phrases, and we can also turn them into documents and queries represented by vectors, matrices, or tuples. That's called algebraic models. So an example of turning them into words, or like word usage in a document, we have an incident matrix. And this is like sort of the basics of how Boolean retrieval is worked. What we do is we find all these individual words and we map them to the document on top here to where we map them to where they occur. So Antony occurs in Antony and Cleopatra, Julius Caesar, and then the rest are 0 until we hit Macbeth, where that word was also used. So to begin using this, we use Boolean math. And I'm not going to go through the basics of how to do that. I hope maybe some of you have done that before. But an example would be a statement Brutus and Caesar and not Calpurnia. So what we do is we would take Brutus, Caesar, Calpurnia, Rose, and then we would add them together using Boolean math, and then we would get this outcome, 100100. And basically what that's saying is Antony and Cleopatra, this one here, and Hamlet. Both of those have this query. Now the problem is with incidence matrix is that it's just way too large. As you can see, the main problem would be that all these zeros are there and we don't need to store that data. So what we can do is make an inverted matrix. And the basics of that is we can find all the words where they do occur and then put them in a postings list. So let's say Brutus is on these documents here. We would have it in this document 1, 2, 4, 11. So we would have those indexes of where it occurs. And the documents don't have to be like a pure document. It can be whatever unit we decide, like paragraphs or sentences, anything like that. And then stored in these postings files. And so now we come to Boolean retrieval models. It's the simplest model to base an information retrieval system on. It was the first and very commonly adopted. Google, for instance, would use it. Queries are Boolean expressions, and search engine returns all documents that satisfy that Boolean expression like we talked about earlier. Boolean queries are queries that use and, or not. So this is the basics of how it works again with a postings list. It will locate Brutus in the dictionary, retrieve it from the postings list, get everywhere that it occurs, then it locates this other word from the postings list, and then it merges them together, and then we have a list of all the documents where it occurs. So my question is how we could possibly improve a Boolean retrieval model.
Using a fully inverted index.
Say again?
Using a fully inverted index.
Let's see. I don't think I caught. Did you catch the whole?
A full inverted index. Instead of using inverted index, use a full inverted index.
Okay, that's one way I did not see. And Some other ways we could do it too is if we had a ranking system that ranked how much it relates to the relevance, and we can also have synonyms for words that could be exchanged for the actual Boolean expression we used.